Welcome to Borishal Cadet College. I am SM Atikur Raja, lecturer, Department of Mathematics, Borishal Cadet College, Borishal. Boys, I hope that you are well by the grace of Almighty Allah. Due to Corona pandemic, I could not take your class in your classroom. I have to take your class virtually. Coronavirus is like the flu. Children very rarely get sick, but it feels like a cold. Be careful and tell your parents or teacher if you don't feel good. Tell an adult or your teacher when you don't feel good, you have a cough, your head hurts. For your safety, stay at home, wear mask, wash your hands. Boys, now I am going to take your higher mathematics second paper class for class 12. Today's topic, motion of a particle moving in a straight line or plane, from chapter 9C. Learning outcome. At the end of the lesson, you will be able to know about determine velocity, determine acceleration, finding resistance uniform, finding time. Formula: V equal to U plus Ft, where V final velocity, U initial velocity, F acceleration, T time. For distance, we use this formula, S equal to ut plus half ft square. Here, v square equal to u square plus 2fs. For average velocity, we use this formula by which we find out distance, initial velocity, final velocity, time. In case of retardation, the equation of motion are as follows. V equal to u minus ft, S equal to ut minus half ft square, v square equal to u square minus 2fs, st equal to u minus half f 2t minus 1. For a specific time, when we finding the distance, we use this formula. Question: prove that for a particle moving with uniform acceleration f in a straight line, f equal to 2 into s prime by t prime minus s by t plus t prime, where s is the space described in t seconds and s prime during the next t prime seconds. Solution: let u be the initial velocity of the first part of the motion. So s equal to ut plus half ft square, where s indicate distance, u initial velocity, t time, f acceleration. If we divide this equation by t, then we get s by t equal to u plus half ft which we indicate equation number 1. Here, initial velocity of the second part equal to final velocity of the first part equal to u plus ft according to our question. Now, s prime equal to u plus ft into t prime plus half ft prime square. If we divide this equation by t prime, then we get s prime by t prime equal to u plus ft plus half ft prime, which is equation number 2. 2 minus 1, that means s prime by t prime minus s by t equal to half ft plus half t prime ft prime. If we take common half f, then we get t plus t prime, half f into t plus t prime. If we change the side, then we get half f t plus t prime equal to s prime by t prime minus s by t. If we multiply this equation by 2, then we get f into t plus t prime equal to s2 first bracket s prime by t prime minus s by t. Finally, if we divide this equation by t plus t prime, we get f equal to 2 into s prime by t prime minus s by t plus t prime, which is our required answer. Short. Now we discuss another problem from chapter 9c. If v1, v2, v3 be the average velocities in 3 successive intervals of times t1, t2, t3 respectively of a point moving on a straight line with uniform acceleration, then show that v1 minus v2 by v2 minus v3 equal to t1 plus t2 by t2 plus t3. Solution. For this, at first we draw this figure where this is point A, B, C, D. Let the point starting from A with initial velocity u and uniform acceleration f reaches at V, C, D and B, C, D and acquire velocity u1, u2, u3 in 3 successive intervals of times t1, t2, t3 respectively. Was the point start from A, where initial velocity u, uniform acceleration f. For the first part AB, this is first part AB, where final velocity u1, initial velocity u, taking time t1, acceleration f. So if we apply here v equal to u plus ft, then we get u1 equal to u plus ft1. For the second part BC, if we apply here v equal to u plus ft formula, then here get u2 equal to u1 plus half plus ft2, where initial velocity u1, final velocity u2, acceleration f, taking time t2. If we put here the value of u1, then we get u plus ft1 plus ft2. But finally we get u2 equal to u plus ft1 plus ft2. For the third part, CD, here u3 equal to u2 plus ft3, but here initial velocity u2, final velocity u3. So we get this formula using v equal to u plus ft. If we put the value of u2, then we get u3 equal to u plus ft1 plus ft2 plus ft3. According to the problem, v1 equal to u plus u1 by 2. But normally we use this formula for average velocity. Here, initial velocity u, final velocity u1. So v1 equal to u plus u1 by 2 for this part. v2, for this part, we get u1 plus u2 by 2. Here u1, u2. v3, for part CD. Here initial velocity u2, final velocity u3. So v3 equal to u2 plus u3 by 2. Whereas now we get v1 minus v2 by v2 minus v3 equal to u minus u2, u1 minus u3. Putting the value of u2, then we get u minus ft1 minus ft2 t2. Here, putting the value of u1 and u3, then we get u plus ft1 minus u minus ft1 minus ft2 minus ft3. U minus u vanish. If we take common minus f, then we get minus f into t1 plus t2. Here u minus u vanish, ft1 minus ft1 vanish. If we take minus common from these two terms, then we get minus f first bracket t2 plus t3. Suppose from this term and this term, we get v1 minus v2, v2 minus v3 equal to t1 plus t2, t2 plus t3, because minus f vanish, which is our required solution. Because now we discuss another problem. A particle starting with a given velocity moves for 3 seconds with constant acceleration, during which it describes 81 feet. The acceleration then ceases, and during the next 3 seconds, it describes 72 feet. Find the initial velocity and acceleration. Solution. Let a moving particle starting with initial velocity u foot per second and uniform acceleration f foot per second square describes a distance 81 feet in time 3 seconds and acquires a velocity v. Then using v equal to u plus ft, we get v equal to u plus 3f. Here t equal to 3 seconds. Using s equal to ut plus half ft square formula, we get 81 equal to thrice u plus half f into 9. Because here distance 81 feet, we use 81 feet time 3, that means thrice u. Here 3 square, that means 9. So if we divide this equation by 3, then we get 27 equal to u plus 3 by 2f, which is equation number 2. If acceleration is inactive, the particle moves 72 feet in next 3 seconds with an average velocity v. using S equal to Vt formula, which is used for average velocity, then 72 equal to 3v. Here distance 72 times 3 seconds. If we divide this equation by 3, then we get v equal to 24. From 1, we get 24 equal to u plus trisep, which is equation number 3. 2 minus 3, that means 3 equal to 3 by 2 minus 3 into f, that means minus 3 by 2 f. From this term and this term, we get f equal to minus 2. From 3, we get 24 equal to u minus 6. That means u equal to 30, because if we change the side here, plus 6, 24 plus 6 equal to 30. So the initial velocity and acceleration of the particle are 30 feet per second and minus 2 feet per second square, which is our required answer. But now we discuss another problem, which is very important. Question: a particle starting from rest moves in a straight line in first with uniform acceleration f1 and then with uniform retardation f2. If it comes to rest in time t measured from the beginning after having described a space as, prove that t equal to root over twice as f1 plus f2 by f1 f2 to t square by twice s equal to 1 by f1 plus 1 by f2. Solution. At first, we draw this figure. Let a particle starting from A with uniform acceleration f1 describes a distance s1 in time t1 and acquires a velocity v at B. Here, the particle is starting from A, where acceleration f1 here describes a distance s1, which indicates this, and acquires a velocity v reached at the point B. Here initial velocity u equal to 0. Then the particle moves from B with velocity v and uniform retardation f2 describes a distance s2 in time t2 and reaches at V. From this, from B to C, it reaches after passing s2 distance and take time t2 and reach at the point C. According to the question, this part is AB equal to S1, BC equal to S2. That is total distance S1 plus S2 equal to S. And total taking time T equal to T1 plus T2, because T1 plus T2. In AB part, V equal to 0 plus F1 T1. If we calculate, then we get T1 equal to V by F1, which is equation number 1. And S1 equal to 0 plus V by 2 into T1. That means VT1 by 2, which is equation number 2. In BC part, 0 equal to V minus F2 T2. That means T2 equal to V by F2, which is equation number 3. And S2 equal to 0 plus V by 2 into T2 equal to VT2 by 2, which is equation number 4. If we add 2 and 4, then we get S1 plus S2 equal to VT1 by 2 plus VT2 by 2. Here, V by T2 equal to, after calculation, we get V by T2 equal to V by 2 into T1 plus T2. That means S equal to V by 2 T. Finally, v equal to twice s by t. If we add 1 plus 3, that means t1 plus t2 equal to v 1 by f plus 1 by f2. From this, we get this equation because t1 plus t2 equal to t. Here v equal to twice s by t and 1 by f1 plus 1 by f2 remaining same, which is equation number 5. But if we want to use, you can use this figure where this AB and BC, this part is VC for your privilege. This is equation number 5, but from this we get t square equal to twice s f1 plus f2 by f1 f2. If we take square root, then we get t equal to square root twice s f1 plus f2 by f1 f2. From 5, we get t square equal to twice s 1 by f1 plus 1 by f2. That means t square by twice s equal to 1 by f1 plus 1 by f2. If we divide this equation by twice s, then we get this equation, which is our required answer. But now we discuss another problem. A train starts from rest at one station and comes to rest at the other. If it moves for the first 1 by m part of the whole distance with uniform acceleration and the last 1 by nth part with uniform retardation, the rest of the distance with constant velocity, prove that the ratio of the greatest velocity to average velocity is 1 plus 1 by m plus 1 by n ratio 1. Solution. Let two stations are A and D and AD equal to D. For this, we draw a figure here, AD equal to D, A, D. Two stations, one station A, another station D. The train is starting from A with uniform acceleration in time t1 and acquires a greatest velocity v at V. Here, the train starts from A with acceleration in time t1 and acquires the greatest velocity v and reaches at V. From B with average velocity v reach at the point C taking time t2. Then starting from C with initial velocity v and retardation reach at D taking time t3. Was now total time t equal to t1 plus t2 plus t3. Here t1, t2 and t3. And average velocity W equal to d by t, where AD equal to d and total taking time small t. Now we use this figure. According to the question, AB equal to d by m, CD equal to d by n, BC equal to d minus d by m minus d by n. Now AB equal to d by m equal to 0 plus v by 2 into t1. From this, after calculation, we get 2d by m equal to vt1, which is equation number 1. BC equal to 1 minus 1 by m minus 1 by n into d. That means vt2 t2, which is equation number 2. And CD equal to d by n equal to 0 plus v by 2 into t3. From this, we get 2d by n equal to vt3, which is equation number 3. 1 plus 2 plus 3, then we get 2d by m equal to vt1, which is equation number 1. 1 minus 1 by m minus 1 by n into d equal to vt2, which is equation number 2. 2d by n equal to vt3, which is equation number 3. After adding, we get 2 by m plus 1 minus 1 by m minus 1 by n plus 2 by n into d equal to v t1 plus t2 plus t3. From this, after calculation, we get 1 plus 1 by m plus 1 by n equal into d equal to vt, because t1 plus t2 plus t3 equal to t. From this, after calculation, we get this equation, because if we divide this equation by t, then we get 1 plus 1 by m plus 1 by n into d by t equal to v. From this, we get this equation, because d by t equal to w. So from this equation, if we calculate, then we get v by w equal to 1 plus 1 by m plus 1 by n, because if we divide this equation by w and change the sign, then we get this equation. So the ratio of the greatest velocity to average velocity is 1 plus 1 by m plus 1 by n ratio 1, because here h is the greatest velocity and w is the average velocity. Well, now we discuss another problem, which is if a point moving under uniform acceleration describes successive equal distances in time t1, t2, t3, then prove that 1 by t1 minus 1 by t2 plus 1 by t3 equal to t by t1 plus t2 plus t3. Solution. At first, we draw the figure. Let a moving particle moving starting from A with velocity u and uniform acceleration in time t1, t2, t3 reach at v, c, d acquires velocity u1, u2, u3, where a, b, b, c, c, d equal to s. Was a moving particle starting from A, this particle starting from A with uniform acceleration. In time t, it reaches v. In time t2, t1 it reaches v. In time t2, it reaches c. In time t3, it reaches d. When it reaches at the point B, it acquires velocity u1. At the point C, it acquires velocity at the u2. At the point D, it acquires velocity u3, where AB, BC, CD are equal distances, which we indicate by S. Otherwise, for first part, AB equal to S, where S equal to Vt, where V is average velocity. Here average velocity u plus u1 by 2 into t1, which is time. If we divide this equation by t1, then we get s by t1 equal to half into u plus u1, which is equation number 1. For second part, b is equal to s u1 plus u2 by 2 into t2. If we divide this equation by t2, then we get s by t2 equal to half u1 plus u2, which is equation number 2. For third part, CD equal to S equal to U2 plus U3 by 2 into T3. If we divide this equation by T3, then we get S by T3 equal to half U2 plus U3, which is equation number 3. Here, AD equal to thrice S, that means U plus U3 by 2 into T1 plus T2 plus T3. From this, we get thrice S by T1 plus T2 plus T3 equal to half U plus U3, which is equation number 4. Now, 1 minus 2 plus 3, then we get 1 by T1 minus 1 by T2 plus 1 by 3 as equal to half U plus U1 minus U1 minus U2 plus U2 plus U3. From this, after calculation, we get half U plus U3. From 4 and 5, we get, this is equation 4 and this is equation 5. 1 by T1 minus 1 by T2 plus 1 by T3 as equal to thrice S by T1 plus T2 plus T3. If we divide this equation by S, we get 1 by T1 minus 1 by T2 plus 1 by T3 equal to 3 by T1 plus T2 plus T3, which is our required answer. Was homework. 1. A bullet loses 1/10 of its velocity in passing through a plank. Find how many such uniform planks it would pass through before coming to rest, assuming the resistance uniform. Number 2. When the distance between two trains running in the same line in the opposite direction with velocities u1 and u2, where u1 greater than u2 is x, each is seen from the other. When f1 and f2 are the greatest retardations produced in respective trains, then prove that it is possible to avoid a collision if u1 square f2 plus u2 square f1 less equal to f1 f2 x. It is just possible to avoid a collision if u1 square f2 plus u2 square f1 equal to 2 f1 f2 x. Boys, coronavirus has stopped our life. Follow these easy steps to help prevent the spread of COVID-19. Disinfect surfaces around your home and work. Wash your hands for at least 20 seconds. Cover your mouth when you sneeze or cough. Try to avoid public gathering. Follow the rules of World Health Organization so that you can save yourself from COVID-19. Thank you.